Good morning, everyone. Welcome to Just Get Civil channel on Academy, and welcome to Mission Gate 2021. We are here for the crash course for Gate 2021, and myself, Soumyajit Sen, discussing with you environmental engineering. Today is the 18th lecture of this series. And just giving you a reminder that if you don't have Unacademy learning app in your mobile or device, go to the Play Store and type Unacademy learning app, install it, and go for the subscription in the plus courses of GATE and EAC. And while taking the subscription, don't forget to apply the code SEN10 ACN10. Don't forget to apply the code SEN10 ACN10. We have already launched a batch on 28th December in English and Hindi both, that is Evolve for GATE 2022. If you have not registered yet, register it right now. Don't be late. It's better to start early for your preparation process. Then we can follow the rule that let's crack it. And while taking the subscription, don't forget to apply the code SEN10 ACN10 SEN10. These are the upcoming batch details. On 11th and 25th of January, so in this 18th lecture, we are entering to chapter 9, that is air pollution engineering. We are entering to air pollution engineering. So we have started in the last class, we have started with the non-water segment of this environmental engineering part. We have already done with the domestic water supply engineering segment, except the distribution system that we will deal after this class, next class. And then we will go for, we have gone for this wastewater engineering. We have completed that, and then we have entered to solid waste management. We have discussed solid waste management. Now coming to the most important non-water segment, that is air pollution engineering. Most important non-water segment, that is air pollution engineering. Now, before going to the details of air pollution engineering, certain things I need to tell. क्या है, जब आप एयर पोल्यूशन इंजीनियरिंग के साथ आप एक्चुअली इतना याद रखिएगा कि एयर पोल्यूशन इंजीनियरिंग is a segment where you have to deal with some arbit things which you haven't thought about. फिलहाल अभी तक भी एनवायरमेंटल इंजीनियरिंग का जितना रिसर्च हो चुके हैं, जहां पे वाटर सेगमेंट मोस्टली इट इज सैचुरेटेड, स्पेसिफिकली डोमेस्टिक वाटर पार्ट, एक्टिवेटेड स्लज प्रोसेस वगैरह अभी भी अंडर रिसर्च हैं, but the air pollution is completely under research. Why? Because dealing with this problem is not that easy. ये ना तो कोई डिस्टेंस मानता है, ना कोई विजिबिलिटी मानता है, कुछ भी नहीं. सबसे बड़ी बात है कि ये कोई एक छोटा जगह के ऊपर डिपेंड नहीं करता है. ये सोचिए कि दिल्ली में कुछ वाटर सोर्स में प्रॉब्लम हुआ, वो वाटर सोर्स पंजाब का प्रॉब्लम, पंजाब में वाटर सोर्स के लिए कोई प्रॉब्लम क्रिएट नहीं करेगा। और जैसे गंगा बेड में इधर आर्सेनिक है, that Ganga bed arsenic is not causing any problem in हरिद्वार, लेकिन एयर पोल्यूशन के लिए चीजें उतना लोकलाइज नहीं है। ये ग्लोबलाइज्ड अप्रोच है, ये कोई बाउंड्री नहीं मानता है कि ये है, मतलब जैसे एक तालाब है, ये सरफेस वाटर रिवर के लिए सोचिए, आप भोपाल में हो, एक लेक में पॉल्यूशन हुआ है, या मुंबई में जो पवाई लेक में जो पॉल्यूशन है, वो पॉल्यूशन इज इट हैम्परिंग द नवी मुंबई पीपल? नो, बट इन केस ऑफ एयर पॉल्यूशन इट कैन. Air conditioner is having a globalized approach. Each and every year in this winter season, you may have heard कि दिल्ली में फ्लाइट देर से पहुंच रहा है या तो देर से मतलब उड़ रहा है, क्योंकि because of the very poor visibility. Vehicular pollution is higher in Delhi, that's it's true, but again during winter season, due to the inversion process, what is inversion I will tell later, lot many pollutants coming from Punjab and Haryana getting accumulated at the Delhi. See, what pollutants? Actually, the Punjab and Haryana farmers, they used to burn their crop residue in the field itself, because that ashes will be acting as a fertilizer. Even you may have heard about the forest fire incident of Amazon. That forest fire is nothing but a natural source of air pollution. The whole Sao Paulo city, which is quite a long away, almost 3,000 kilometers away from the Amazon core forest. But due to that burning process, forest fire, Sao Paulo city turns into darkness. So air pollution engineering doesn't localized process. It's a globalized approach. Again, पानी में कुछ pollutant, pure water, free from anything. पानी का कुछ प्रॉब्लम, सोचिए आर्सेनिक है पानी में, उसको क्या करेंगे आप? उसको जीरो करना है, स्ट्रेट फॉरवर्ड आपका दिमाग में है कि उसको जीरो करना है. इट्स बेटर टू डील विद दिस अप्रोच. वेयर एयर पोल्यूशन के लिए कहानी अलग है. कौन है पोल्यूटेंट? अपने खुद का रिश्तेदार है पोल्यूटेंट. सल्फर ऑक्साइड constituent of air itself, oxides of carbon constituent of air itself, oxides of nitrogen constituent of air itself, but they are acting as pollutant beyond a certain limit. They are acting as pollutant beyond a certain limit, and that is the problem actually, when the constituent of air itself acting as pollutant beyond a certain limit. That's why it is not feasible to make it zero. आपको हमेशा एक अपर लिमिट और लोअर लिमिट के बीच में कहानी को मेंटेन करना है. मतलब अगर आप किसी को किडनैप करके लेके आए हो, उसको अगर मार दे रहे हो तो भैया खर्चा नहीं है, कुछ भी उठा के लाओ और मार दो. लेकिन किडनैप करके लाए हो और उसको जिंदा भी रखना है, तब थोड़ा मगजमारी करना ही पड़ेगा. Now, there are different sources of air pollutant: natural source and man-made source. Natural source example is volcano eruption, forest fire. In volcano eruption, huge amount of sulfur oxide gases will be evolved. In forest fire, huge amount of hydrocarbons getting burned, so carbon dioxide gases will be huge. Man-made source will be any kind of industrial source and automobile source. Before going to the details, here I am showing you one particular plot of altitude or height versus temperature. From the base, from the ground surface to up to 12 kilometer, we will observe the reduction in temperature with height, which is called as troposphere. From 12 to 50 kilometer height, we will observe opposite to the tropospheric situation, that is increase in temperature in height, that is stratosphere. From 50 to 90 kilometer, we will observe again the reduction in temperature with height, that is mesosphere, and beyond 90 kilometer, we will observe increase in temperature with height, that is ionosphere. And generally, what is the highest point on earth? That is Mount Everest, that is 8,950, almost is 9 kilometer. So everything is under tropospheric region, so we are actually concerned about the troposphere itself. Clear? Then the man-made source will be of two types: static और moving. Static मतलब जो एक जगह पे fixed है, that is the industry, and moving मतलब which will actually move from one place to another, that's nothing but an automobile, or it can be a point source or aerial source. आपको एक एग्जांपल जस्ट बताना चाहता हूं, ये जो मैं ग्लोबलाइज्ड अप्रोच के बारे में बता रहा था, जो लोग मुंबई में हैं या महाराष्ट्र में रहते हैं या मुंबई घूमे हुए हैं, आपको जानते हैं कि चेंबूर बोल के एक जगह है मुंबई और नवी मुंबई के बीच में, जो इंडस्ट्रियल एरिया है. हम लोग जब मास्टर्स करते थे आईआईटी में, तो वी आर एक्चुअली फाइंडिंग आउट दैट विच पोर्शन ऑफ आईआईटी इज एक्चुअली गेटिंग इफेक्टेड बाय एयर पोल्यूशन मोस्ट. द आयरन इज, हमारे जो डिपार्टमेंट था एनवायरमेंटल इंजीनियरिंग का, उसका छत जो है वो सबसे ज्यादा खराब था एयर पोल्यूशन के हिसाब में. एंड मोस्ट ऑफ द values, actually the type of pollutants, all are evacuated or discharged from the Chembur industrial region, which is around 35 to 36 kilometers away from Powai. It's 35-36 किलोमीटर तो बहुत छोटा बात हो गया. अभी मैं साओ पाउलो का जो एग्जांपल दिया, 2-3 हजार का कहानी है. मतलब सोच लीजिए मुंबई से कलकत्ता है 1950 किलोमीटर. कलकत्ता में कुछ हुआ, उसका इफेक्ट है मुंबई में. एक समुद्र का डिस्टेंस कवर कर लेता है. Anyways, now we are going for the type of air pollutant. The different types of air pollutants are, first, a primary air pollutant. The constituent of air which will act as pollutant immediately after they got released from source is called as primary air pollutant. The constituent of air which will act as pollutant immediately after they got released from source is called as primary air pollutant. As example, COX, NOx, SOX, VOC, PM, hydrocarbon, etc. Oxides of carbon, oxides of nitrogen, oxides of sulfur, volatile organic compounds, particulate matter, hydrocarbon, etc. The constituent of air which will act as pollutant immediately after they got released from source. Secondary air pollutant will be when two or more than two primary pollutant reacts with each other and form a new set of pollutant. When two or more than two primary air pollutant reacts with each other and form a new set of pollutant, then it is called as secondary pollutant. As example, PAN, peroxyacetyl nitrate, PBN, peroxybutyl nitrate, etc. Now, as per NAC, National Ambient Air Quality Standard. They have identified 6 pollutants. They have identified 6 pollutants. Those are most detrimental to human health. So according to the health effect, they have identified 6 pollutants, and these 6 pollutants, they can be primary pollutant, can be secondary itself, but this 6 pollutant called as criteria pollutant. 6 pollutant is called as criteria pollutant. This is identified, these names are identified by NAQ, National Ambient Air Quality Standard, an organization based in USA, which is actually considered as the mother organization of air pollution process. They are CO, carbon monoxide, mind it, not carbon dioxide, only carbon monoxide, NOx, NOx, SOx, oxides of sulfur, lead, Pb, ozone, and PM, particulate matter. अब यहाँ पे कार्बन मोनोक्साइड, ठीक है, हम जानते हैं बचपन से कार्बन मोनोक्साइड के बारे में बहुत कुछ सुने हैं. तो कार्बन मोनोक्साइड के बारे में बहुत कुछ सुने हैं. NOx, SOx भी ठीक है. लेड ओके, we have heard about this. We are mainly concerned about ozone, क्यों, and PM, particulate matter, who, कौन है ये. सबसे तो पहला है कि ओजोन. ओजोन के बारे में, ओजोन हम लोग जब वाटर पढ़ रहे थे तब हम देखे हैं कि ओजोन इज यूज्ड एज डिसइंफेक्टेंट. उससे हम लोग माइक्रो ऑर्गेनिज्म को मार रहे हैं, और जब, एंड इट इज एक्चुअली द मोस्ट एफिशिएंट डिसइंफेक्टेंट कैन बी यूज्ड फॉर वाटर ट्रीटमेंट, वेयर वी विल किल द माइक्रो ऑर्गेनिज्म नॉट ओनली but also it will be used to remove manganese, iron, volatile organic compounds from water. सबसे बड़ी बात है कि बचपन से ये सुनते आए हैं कि ओजोन लेयर है, इसीलिए हम लोग बचे हुए हैं यूवी रेज से. वो डिप्लीट हो चुका है अंटार्कटिका रीजन में, इसीलिए यूवी रेज आर कमिंग. दैट्स व्हाई वी आर एक्सपोज्ड टू स्किन कैंसर. एंड नाउ वी आर टेलिंग कि भैया वो लश्करी तैयबा का जो है, उसको वहां का एक बहुत मतलब मशहूर एक आदमी है जिसको पकड़ना है. क्राइटेरिया पोल्यूटेंट इज लाइक दैट ओनली. We are putting that name in that list which is most wanted, this type of thing. It's a don. Why? Why ozone? इसको समझने के लिए हमको समझना पड़ेगा photochemical smog. And smog, the term is actually coming from smoke plus fog, where fog is our natural phenomena, but the smoke is photochemical smoke. What is that smoke? The smoke is the oxides of nitrogen in the presence of sunlight. They react with each other and form a new set of secondary pollutant like ozone, formaldehyde, PAN, PBN, etc. तो ये जो स्मोक जो तैयार होता है, जो सेट ऑफ गैस, जो secondary pollutant along with the fog, they create a cover above the atmospheric surface and they create zero visibility. 3-4 साल पहले आप एक एक्सीडेंट के बारे में सुने होंगे. यमुना एक्सप्रेसवे में 24 गाड़ियों का सीरीज ऑफ एक्सीडेंट हुआ था ड्यू टू जीरो विजिबिलिटी एंड ड्यू टू दिस फोटोकेमिकल स्मॉग. तो फॉग का तो आपके हाथ में नहीं है, वो नेचुरल प्रोसेस है, वो छोड़ दीजिए, दैट इज गुड. सर्दी के मौसम में फॉग हमेशा ही होगा, वो होना ही है. वो नहीं होगा तो आपका इकोसिस्टम पैरामीटर सही नहीं है. लेकिन दिस स्मोक इज एक्चुअली द पोल्यूटेंट पार्ट. और स्मोक बना कौन रहा है? कोई अकेला बंदा नहीं बना रहा है, एक टीम बना रहा है. व्हिच इज द टीम? ओजोन, पैन, पीबीएन, एचसीएचओ, ऑल द टीम. अब बात है कि फिर से हम एक पुराना एग्जांपल दे रहे हैं. आप जानते ही होंगे, जो लोग क्रिकेट को फॉलो करते हैं, कि कुछ दिनों का पहले का कहानी है. स्टीव स्मिथ और डेविड वार्नर को सस्पेंड किया गया 1 साल के लिए, उसका कैप्टेंसी छीना गया. Why? Because they are actually accused in ball tampering. तो बॉल टेम्परिंग एक्विजिशन इज फॉर द होल ऑस्ट्रेलियन टीम। ऐसा नहीं है कि जो बॉलर बॉल करने जा रहा था उसको मालूम नहीं है कि उसका बॉल जो है वो टेम्पर्ड था, और ऐसा नहीं है कि फील्डर को मालूम नहीं था। लेकिन सिर्फ स्टीव स्मिथ और डेविड वार्नर क्यों? क्योंकि कुछ खराब अगर कुछ टीम करता है तो उसका कैप्टन और वाइस कैप्टन के ऊपर आता है। तो ये ऐसा ही एक टीम खराब कर रहा है, स्मोक बना रहा है, जिसका कैप्टन है ओजोन, क्योंकि सबसे ज्यादा परसेंटेज ओजोन तैयार होता है। दैट्स व्हाई ओजोन इज कमिंग टू दिस प्रोसेस ऑफ क्राइटेरिया पॉल्यूटेंट। अंडरस्टूड? सो इन ब्रीफ वी कैन से दैट स्ट्रेटोस्फेरिक ओजोन इज गुड, क्योंकि स्ट्रेटोस्फेरिक ओजोन वही ओजोन है जो हमको बचा रहा है यूवी रेज से। दैट इज नॉट इन ट्रोपोस्फियर, that is beyond 12 kilometer, that is in stratosphere where generally the flight is moving. But tropospheric ozone is bad, which is formed in the troposphere region, that is bad. And in the water treatment process, what ozone we are producing, it's the artificial ozone we are producing in it, in the by producing a by generating a high electricity field in the ozonator instrument. That is good. So स्ट्रेटोस्फेरिक ओजोन इज गुड एंड ट्रोपोस्फेरिक ओजोन इज बैड। ये चीज को आप अपने खून में बवा लीजिए। नाउ कमिंग टू पार्टिकुलेट मैटर। पार्टिकुलेट मैटर ऐसा है कि ये वही चीज है जो सबसे छोटा चीज है लेकिन सबसे ज्यादा तंग करता है। क्यों? सबसे बड़ा चीज है कि सोचिए आप किसी को इरिटेट करने का कोशिश कर रहे हो, बंदा इरिटेट हो गया तो आपको बहुत मजा आता है, लेकिन अगर बंदा इरिटेट नहीं हुआ तो आप इरिटेट हो जाते हो। पीएम वैसा है, आप कुछ भी कर लो इरिटेट नहीं होता है। नॉन रिएक्टिव, इजीली गेट्स इनटू द लंग्स एंड गेट डिपोजिटेड इन द बॉटम। एक बार डिपोजिट हो गया उसको हिलाना मुश्किल है, शांत से बैठा रहेगा, कुछ नहीं होगा, इंसान का मौत होगा। पार्टिकुलेट मैटर मीन्स द पार्टिकल्स प्रेजेंट इन द एयर इन सस्पेंशन। कभी ये बचपन में भी देखे होंगे, अगर गांव की तरफ घर वर है तो कई घर पे अगर बाहर से धूप आ रहा है तो इन द एयर यू विल सी लॉट मेनी सस्पेंडेड एयर पार्टिकल्स, और इफ यू पुट अ टॉर्च लाइट you will also observe lot many particles in air, and those particles we are continuously inhaling, they are particulate matter. But if the particulate matter diameter is more than 10 micrometer, then that will be restricted by the hairs in our nostrils. They are actually acting as the filter media. But if the particle diameter is less than 10 micrometer, it will not be able to restrict it. They are called as PM10. Those diameter ranges between 2.5 to 10 micrometer. And if the diameter is less than 2.5 micrometer, it's called as PM 2.5. This PM 2.5 and PM 210 are the dangerous particulate matter, as they can easily enter through our nostrils and go to the pulmonary vessels and lungs and get deposited. जितना छोटा उतना भयंकर, जितना छोटा डायमीटर उतना इजी पैसेज। एक छोटा सा आपको एग्जांपल दे रहा हूं। आप चौक डस्ट देखे ही होंगे बचपन में। हाथी देखे हैं? एडल्ट एलिफेंट? मैं नहीं। और एडल्ट एंट, चीटी? Can you please tell me what is the size difference between an adult elephant and adult ant? 10 to the power 1 lakh, 10 lakh. Your chalk dust is adult elephant and PM 2.5 is adult ant. Then you can understand what small particle I am talking about. Okay. Now, the unit and expressions of concentration of air pollutant. Generally, they are expressed in ppm, ppb, and microgram per meter cube. It's not like the water one. So PV equals to nRT, we know, as STP, standard temperature and pressure. P will be, which is P is 1 atmosphere, T 273 Kelvin, and R universal gas constant in atmosphere meter cube by mole Kelvin 82.05 10 to the power minus 6. Molecular weight of gas is m. We know that at STP 1 mole of any gas will occupy 22.4 liter volume. That is known to us from class 7. So we can say that 22.4 liter of any gas weighs m gram, or we can say 22.4 into 10 to the power minus 3 meter cube of any gas weighs m gram. Just liter to meter cube conversion. So 1 meter cube of any gas weighs m by 22.4 into 10 to the power minus 3 gram. What is 1 ppm? 1 parts per million. That means 1 part of any gas by 1 million of air. And 1 million of part of air means 10 to the power 6 part of air. So from equivalency concept, from part to any meter I can go. So 1 meter cube of any gas by 10 to the power 6 meter cube of air. And 1 meter cube of any gas weighs, already we have gone through that m by 22.4 10 to the minus 3. So here I am getting 1 ppm is equals to m by 22.4 into 10 to the power 3 gram per meter cube. Clear? Or 1 ppm is equals to, I'm just gram to microgram. It is 1 ppm is equals to m into 10 to the power 3 by 22.4 microgram per meter cube, or 1 microgram per meter cube is equals to 22.4 into 10 to the power minus 3 by m ppm. From here, 1 microgram per meter cube is equals to 22.4 by m ppb, or 1 ppb is equals to m by 22.4 microgram per meter cube. These are all the expressions. Please have a look. Now, the standards and health effect of criteria pollutant according to the NAC, National Ambient Air Quality Standard. This is a tab table I have formed here. You don't have to go for any books and everything. Everything is there in your note. Pollutant name carbon monoxide. Exposure time 8 hours and 1 hour. Standard for 8 hours is 9 ppm, 1 hour is 35 ppm. What does it mean? It means that if carbon monoxide is present in an air sample, you can sustain there for 8 hours if the concentration is not more than 9 ppm. Or in contrary, I can say that you can sustain in that air for 1 hour if the concentration is not more than 35 ppm. This carbon monoxide reacts with hemoglobin and form carbaminohemoglobin, which decreases the ability to transport oxygen by blood and causes premature death. Also causes dizziness and extreme headache. एक्चुअली क्या होता है कि कार्बोमिनो हीमोग्लोबिन जब बन जाता है दैट इज इरिवर्सिबल, वहां से आप हीमोग्लोबिन का आयरन सेगमेंट को दोबारा लौटा नहीं पाओगे. नेक्स्ट इज lead. Exposure time 3 months. Standard is 1.5 microgram per meter cube. Health effect: improper blood formation and effect in infant development. Next is NOx. Exposure time 1 year and standard is 0.25 ppm. Health effect: chronic bronchitis, effect in vegetation growth. Next is ozone. Exposure time 8 hours and 1 hour for 8 hours. The standard is 0.08 ppm. For 1 hour, the standard is 0.09 ppm. That's giving as decrease in pulmonary function, eye irritation. SOX 24 hour and 1 hour. Standard 0.04 ppm and 0.25 ppm. Will show respiratory tract problem, effect in building material. PM10 and PM2.5, exposure time 24 hour and both the cases. Standard is 150 microgram per meter cube and 35 microgram per meter cube. Health effects: asthma, painful breathing, chronic bronchitis, headache, decrease in pulmonary function, finally premature death. Have a look. Now, this is the thing that is, क्या है अभी तक जो हम पढ़े हैं उसमें क्या था कि डिफरेंट क्राइटेरिया पोल्यूटेंट के लिए डिफरेंट आपका पैरामीटर्स हैं, उसका स्टैंडर्ड्स हैं, लिमिट्स हैं। अब अगर आपको कोई एक आम आदमी ने पूछा कि एयर का कैसा है एयर, what will be your answer? Previously the measurement process is voluminous process. What will be your answer? क्योंकि हो सकता है कोई एयर में कार्बन मोनोऑक्साइड बहुत ही कम है लेकिन उसमें पार्टिकुलेट मैटर बहुत ज्यादा है। जैसे कलकत्ता का एयर में, वहां पे कलकत्ता is actually under those cities which are having very poor air quality. In 2007, 6 to 7, a 6 city studies was done by CPCB, Central Pollution Control Board. They have identified 6 cities in India with having very poor air quality. In Kolkata was one of them, but in Kolkata city there is no industry. But why? Because of particulate matter. तो कोलकाता में SOx का अमाउंट कम है बिकॉज द थर्मल इंडस्ट्री इज नॉट देयर, बट पार्टिकुलेट मैटर का अमाउंट के लिए इसका वैल्यू ऐसा है। तो पॉइंट है कि मैं क्या बोलना चाहता हूं कि अगर कोई आपसे पूछे then answering that person is very tough. Answering that person is very, very tough. That's why a process of air quality index where a color code and a number will be introduced to define, like बोल देगा कि कैसा है एयर क्वालिटी इंडेक्स, की बोल दीजिए सोचिए 55, 55 और 100 like this. In India in 2014, under such Bharat mission, this is introduced. Where 6 color codes are there and values are there and description of air quality is given. And they are considering the 5 pollutants. What are the 5 pollutants they are considering? Apart from lead, everything, every criteria pollutant. CO, NOx, sorry, SOx, ozone, and PM. These 5 they are considering. You can search it in your Google that what is AQI of Delhi, air quality index of Delhi, or air quality index of Kolkata or any place. You will find this. 5 pollutants, but 6 color codes. For 0 to 50, it will be in green color code. Good air, air quality satisfactory, air pollution poses little or no risk. If it's in between 51 to 100, moderate, acceptable. If it is 101 to 150, orange. 150 to 200, it's red. 201 to 300 is purple, and 301 and higher is maroon, hazardous. Lot many times you will get Delhi AQI as maroon, hazardous. Have a look on this air quality index part. This is introduced this year, so chances of getting questions from this segment will be higher. This is introduced this year. Theoretical part. Now we are going for certain measurements and techniques for different pollutants. First of all is particulates or SPM or TSP, total suspended solids. There are two types: solid particles like dust, smoke, fume, and liquid particles like mist and spray. They will be measured by high volume sampler. There are certain other sampler also like low volume sampler, moody, etc. What will happen? There will be a filter paper which initial weight will be taken first, and a volume of air will be passed through it, and final weight will be measured, and so that suspended particles, particulate matters will be restricted in the filter paper, whatever it may be. Then you will find out the concentration by weight final minus weight initial by the volume of air sampled. Volume of air sampled is nothing but the average rate of sampling into time. Okay. Particulate control devices will be dry control device. Dry control device without water and wet control device. Dry control device are more reliable than the wet control device. Wet control device will be spray tower, cyclone scrubber, and venturi scrubber. Number one dry control device is gravity settling chamber, which can deal with the diameter more than 10 micrometer, and efficiency will be less than 50%. Second is cyclone separator, which will deal with the diameter 5 micrometer to 25 micrometer. Efficiency will be in between 50 to 90%. Electrostatic precipitator where diameter greater than 1 micrometer, efficiency 95 to 99%. Fabric filter diameter less than 1 micrometer, efficiency more than 99%. And efficiency of ESP will be defined by the equation eta is equals to 1 minus e to the power minus WA by Q. 1 minus e to the power minus WA by Q, which is called as Deuss-Anderson equation. Which is called as Deuss-Anderson equation. Just have a look. Where in the Deuss-Anderson equation, Q is the air fluid in meter cube per second, A is the collector plate area in meter square, and W is the effective drift velocity, which is fixed for a particular process. Now, carbon monoxide. It is colorless, odorless, tasteless, inert gas with average residence time of 2.5 months. It is mostly emitted from the automobiles. It is mostly emitted from the automobiles. It is measured by NDIR analysis, non-dispersive infrared analyzer. It is measured by NDIR analysis. Then SOX. Just informations are there which will be important for your MCQ type questions. Among all oxides, SO2 is more dangerous. SOX is mostly emitted by burning of fossil fuel. SO2 is pungent smell, suffocating gas, and having average residence time of 2 weeks. It is pungent smell, suffocating gas, and having average residence time of 2 weeks. It is measured by West and Geick method. It is measured by West and Geick method. It is measured by West and Geick method. NOx. Among all forms of NO and NO2 are more dangerous. It is measured by Jacob-Ochicer method. We need to know this Jacob-Ochicer method. Then hydrocarbon, it is measured by gas chromatography method. This is the information we need to remember. To note that FBC, fluidized bed combustion, and FGD, flue gas desulfurization, the industrially used to control the oxides of sulfur. Have a look on this process. Now we are entering to the second lab of this chapter, which is called as air pollution meteorology. Which is called as air pollution meteorology. क्या चाहिए देखने से पहले हम लोग देखते हैं कि क्या चाहिए. सोचिए, certain amount of pollutant is dispersed. Certain amount of pollutant is dispersed in your room. It may be detrimental. Suppose 60 microgram per meter cube of sulfur dioxide is discharged in your room. It is detrimental. The same sulfur dioxide, if it is discharged for your area, dilution occurred. If that same sulfur dioxide is discharged for a whole city, further dilution occurred. If the same sulfur dioxide is discharged for the whole state, more dilution is occurring. Right? So what is required? Dilution is required. How this dilution will happen? By the dispersion. How this dilution will happen? By the dispersion. And this dispersion can be done naturally also. And this natural dispersion is affected by some parameters. The natural dispersion is affected by some parameters, and they are called as meteorological parameters. This natural dispersion is affected by some parameters, and they are called as meteorological parameters. And the study of this effect is called as air pollution meteorology. The study is called as air pollution meteorology. And what are the meteorological parameters? Temperature, wind speed and direction, pressure, humidity, etc. What are the meteorological parameters? Temperature, wind speed and direction, pressure, humidity, etc. First, we are going for the temperature. That is a major meteorological parameter which will define this temperature will define the vertical dispersion. कितना ऊपर जाएगा pollutant, जितना ऊपर जाएगा उतना अच्छा है, और ऊपर जो जाएगा ऊपर जाने वाला कहानी जो है वो डिफाइन होगा टेम्परेचर से. Now we know, as we are concerned about the troposphere region, we know if we plot altitude versus temperature, then we are going to get a reduction in temperature with height. And dT/dz, rate of change of temperature with height, is called as the lapse rate, which is 10 degree centigrade per kilometer reduction, or ideally it is 9.8 degree centigrade per kilometer. मतलब 1 किलोमीटर ऊपर जाओगे तो आपका 10 डिग्री सेंटीग्रेड टेम्परेचर घटना चाहिए. अगर बेस लेवल पे है 40 डिग्री सेंटीग्रेड का टेम्परेचर, 1 किलोमीटर ऊपर जाने से आपका टेम्परेचर 10 डिग्री घटेगा. दैट विल बी 30 डिग्री सेंटीग्रेड. Now this value 10 degree centigrade or 9.8 degree centigrade, this value is actually estimated by assuming the whole process. This value is estimated mathematically by assuming the whole process as adiabatic process. That's why it is called as ALR, adiabatic lapse rate, or dry adiabatic lapse rate. That's why it is called as adiabatic lapse rate or dry adiabatic lapse rate, DALR. Okay. Now there are the actual lapse rate, that is the ideal one. The actual lapse rate is called as environmental lapse rate or ELR. The actual lapse rate is called as environmental lapse rate or ELR. Now the question is, there are three conditions: ELR greater than ALR, ELR equals to ALR, and ELR less than ALR. अगर आपका environmental lapse rate ALR मतलब adiabatic lapse rate से ज्यादा होते हैं तो उस एटमोस्फियर को कहते हैं अनस्टेबल एटमोस्फियर. उस एटमोस्फियर को कहते हैं अनस्टेबल एटमोस्फियर, एंड द कंडीशन इज कॉल्ड एज सुपर एडियाबेटिक कंडीशन. ज्यादा मतलब सोचिए एएलआर का वैल्यू क्या है, 10 डिग्री सेंटीग्रेड पर किलोमीटर का रिडक्शन है, तो सोचिए 15 डिग्री सेंटीग्रेड पर किलोमीटर का रिडक्शन हो रहा है. देन एएलआर इज मोर देन एएलआर अनस्टेबल एटमोस्फियर सुपर एडियाबेटिक कंडीशन. If ELR is equals to ALR, which is neutral atmosphere, and अगर ELR is less than ALR, then it will be called as a stable atmosphere, and the condition is called as subadiabatic condition. अब हमें देखना है कि कौन सा केस में वर्टिकल डिस्पर्सन अच्छा हो रहा है और कौन सा केस में सबसे खराब, मतलब कौन सा टाइप ऑफ एटमोस्फेयर वी रिक्वायर फॉर द पॉल्यूटेंट डिस्पर्सन and the which this process is not required for pollutant dispersion, is not desired for pollutant dispersion. Have a look. Now let's go to the description process. Very important, a schematic diagram is there. I have drawn this. Very important. Try to understand what is happening. Please try to understand what is happening. This is case A. This is case B. This is case C. In case A, we are following ELR greater than ALR as an example, 15 degrees centigrade per kilometer reduction. Case B is neutral atmosphere, 10 degrees centigrade per kilometer. Case C is less than. Now suppose a air mass, a balloon has released in the ground surface, जब जो जिसमें पॉल्यूटेंट है और टेम्परेचर 40 डिग्री सेंटीग्रेड और एम्बिएंट टेम्परेचर 35 डिग्री सेंटीग्रेड, हर चीज में सेम कंडीशन। तो मैं अगर क्या चाहिए मुझे, वर्टिकल डिस्पर्सन तभी होगा जब आपका बलून का टेम्परेचर एम्बिएंट टेम्परेचर से ज्यादा होगा, क्योंकि मोर टेम्परेचर मींस लेसर डेंसिटी। कम होता है तो किसी केस में भी ये ऊपर नहीं जाएगा। तो इनिशियल कंडीशन पकड़ लेते हैं कि हर केस में ऊपर जाएगा, उसके बाद देखते हैं कि कौन ज्यादा ऊपर जाता है, कैसे जाता है। फॉर दिस केस 40 से चालू, और जो एयर मास और बलून है वो हमेशा एएलआर को फॉलो करेगा, ड्राई एडियाबेटिक लैप्स रेट मतलब 10 डिग्री सेंटीग्रेड पर किलोमीटर को फॉलो करेगा। तो चलिए ये जाएगा 1 किलोमीटर तक, और 40 घट के हो गया 30 और 35, जैसे ये इसका 15 करके रिडक्शन है तो 35 घट के हो गया 20। फिर से बलून का टेम्परेचर ज्यादा तो फिर से ऊपर जाएगा, 1-2 किलोमीटर में हाइट में जाके इसका टेम्परेचर 30 से करके 20 और इसका 5। इसमें बलून का टेम्परेचर ज्यादा फिर से ऊपर जाएगा। तो ऐसे देखते देखते ये 3 या 4 किलोमीटर ऊपर चला जाता है, तो जो बंदा नीचे है उसके लिए कुछ फर्क ही नहीं पड़ेगा। करेक्ट। कमिंग टू केस बी, 40 और 35 से चालू दोनों का ही 10 डिग्री सेंटीग्रेड का रिडक्शन है। ऊपर 1 किलोमीटर में जाएगा 30 और ये 25, फिर से ये ऊपर जाएगा क्योंकि इसका टेम्परेचर ज्यादा है 20-15, फिर से जाएगा 10 डिग्री सेंटीग्रेड और 5 डिग्री सेंटीग्रेड है, तो चलता ही जाएगा। अब क्वेश्चन है, तो केस ए और केस बी में कोई अंतर नहीं है? अंतर है। आप देखिए ये जो ऊपर जाने वाला कहानी है ये किससे डिफाइन होता है? जितना ज्यादा टेम्परेचर का गैप होगा, जितना ज्यादा टेम्परेचर डिफरेंस होगा, उतना वाइब्रेंट होगा मूविंग। आप केस ए में देखिए टेम्परेचर डिफरेंस लगातार बढ़ते जा रहा है, मतलब ऐसे ऐसे वाइब्रेंटली इट विल मूव अप, वाइब्रेंटली इट विल मूव अप। But in case B, it will move up, but it will in a constant rate. In case A, quickly it will dissolve toward the upward atmosphere. So vibrantly it will move up. But in case B, it will be done in a constant rate. It will not be mixed in quickly. केस सी में क्या हो रहा है? 40 गया, 35 ऊपर गया 1 किलोमीटर में, 40 हो गया 30 और बगल वाला 35 भी हो गया 30। तो भैया क्या हुआ, 1 किलोमीटर वाला वहां पे इक्विलिब्रियम कंडीशन रीच कर गया, और ऊपर तो नहीं जाएगा, उधर ही स्टैग्नेंट हो जाएगा। मतलब 1 किलोमीटर ऊपर मतलब बहुत कम ही ऊपर में जो इंसान है वो पॉल्यूटेंट में एक्सपोज हो गया। तो विच इज बेस्ट? विच इज बेस्ट? केस ए इज बेस्ट। विच इज वर्स्ट? केस सी इज वर्स्ट। Case A is best, case C is what? Worst. So what is the best situation? When ELR greater than ALR means super adiabatic condition. जिंदगी में आपको हर चीज में चाहिए स्टेबिलिटी। जिंदगी में आपको हर चीज में स्टेबिलिटी चाहिए। मम्मी पापा बोलेंगे कि जॉब ले लो स्टेबिलिटी मिल जाएगा, लेकिन ओनली फॉर द एयर पोल्यूशन डिस्पर्सन यू रिक्वायर अनस्टेबिलिटी, बिकॉज अनस्टेबिलिटी मीन्स more dispersion of air pollutant, which will be good for your health. That is the only place where you require instability condition. So case A, vertical dispersion with extensive rate, vertical dispersion with fixed rate in case B, and case C is stagnancy after certain height. So instability in the atmosphere is required to get maximum dispersion. Have a look. Now one thing, if it's your ALR line, so which segment, though it's noted here, which segment of the ALR line is your showing instability, and which segment means left hand side is showing what and right hand side is showing what. Just example, suppose this is your ALR line, and in left hand side I have taken one ELR2 line, ELR1 line right hand side in 1 kilometer. Height, so obviously which is taking there like this will be your 40 degrees centigrade. It is showing something less than 40, so 35 I'm taking. It is something showing something in between 40 to 50. So DLR1 is showing DTDZ of 5 degrees centigrade, 50 to 45 reduction. कितना घटा 1 किलोमीटर में 5 डिग्री सेंटीग्रेड पर किलोमीटर, लेस देन एयर स्टेबल एटमॉस्फेयर. और ये कितना घटा 15 डिग्री, ये क्या है ग्रेटर देन एयर अनस्टेबल एटमॉस्फेयर. दैट मींस the left hand side of ALR line, the left hand side of ALR line will show you instability. The left hand side of ALR line will show you instability, and the right hand side of ALR line will show you stability. The left hand side of ALR line will show you instability, and the right hand side of ALR line will show you stability. Well, look on this process. Now, now we are going for a very important thing which is called as temperature inversion. This is an atmospheric condition in which a layer of warm air traps the cold air. मतलब नीचे cold air, ऊपर warm air. It generally occurs in winter night. इसका मतलब क्या है, जब हाइट बढ़ेगा आपका टेम्परेचर भी बढ़ रहा है. इन्वर्सन मतलब उल्टा. when DTDZ is positive, that means DTDZ is positive, that means your temperature is increasing with height. That is called as temperature inversion. It is of three types. Extreme inversion, when inversion starts from ground and continues. यहाँ पे सबसे महत्वपूर्ण चीज जो है, इन्वर्सन एक ढक्कन की तरह एक्ट करता है, कोई भी इसको क्रॉस नहीं कर पाएगा. सो ये लीड का ये इन्वर्सन इज एक्टिंग एज अ लीड. व्हाट इज द जॉब ऑफ दिस लीड? इट इज नॉट अलाउइंग द आउटसाइड गैस टू कम or outside things to enter to this bottle, or not allowing the inside things to go out from this bottle. So this that is, so it is acting as a lead. तो इन्वर्सन के ऊपर कुछ भी है तो वो नीचे नहीं आ पाएगा. हम जो दैट इज गुड बिकॉज हम नीचे हैं, हम देखते हैं कि ऊपर जितना भी चले जाए कोई दिक्कत नहीं है, लेकिन इन्वर्सन के नीचे कुछ भी है वो ऊपर नहीं जा पाएगा, दैट इज बैड। तो इन्वर्सन के ऊपर कुछ भी इज गुड, इन्वर्सन के नीचे कुछ भी इज बैड। ओके, is acting as a lead. Now the second type is subsidence inversion. Subsidence inversion में क्या होता है कि पहले होता है आपका inversion, पहले होता है आपका inversion, after certain height there will be super adiabatic condition, ये लग रहा था नहीं लगा। And the one is residence inversion, subsidence inversion से पूरा ही उल्टा, where पहला होता है आपका ये greater than a, उसके बाद है आपका inversion height। Okay, just have a look. Now we're going for wind. So temperature is actually defining the vertical transport. Wind will define the horizontal transport. So air in motion is called as wind. The horizontal transport of pollutant will be defined by wind. According to wind, atmospheric will be of two types. Windy atmosphere or unstable atmosphere were good for pollutant dispersion, and calm atmosphere or stable atmosphere which is not good for pollutant dispersion. So windy atmosphere or unstable atmosphere, it is good for pollutant dispersion, and calm atmosphere or stable atmosphere, it is not good for any kind of pollutant dispersion. Wind is measured by anemometer instrument. Wind is measured by anemometer instrument. Wind is measured by anemometer instrument. Wind direction is estimated by wind vane. Wind direction is estimated by wind vane, and wind data of any place will be represented by wind direction is estimated by wind vane. Wind data of any place will be represented by wind rose diagram. Wind data of any place will be represented by wind rose diagram. And wind speed at any height measured by 1/7th law, where V by V naught is equals to Z by Z naught to the 1/7, where V naught is the wind speed at height Z naught and V is the wind speed at height Z. Now pressure. There are two type of pressure system. One is high pressure system or anticyclone, another one is low pressure system or cyclone. Low pressure system is good for pollutant dispersion, where atmospheric pressure is measured by barometer. Okay. And finally, so wind is horizontal dispersion, pressure will be in any direction. Finally, it's humidity. Moisture in atmosphere is known as humidity. It is having no effect on pollutant dispersion, but the quantity of secondary pollutant generated will largely affected by humidity. In terms of humidity, it will be of two types: dry atmosphere or humid or wet atmosphere. Secondary pollutant generation will be more in the wet atmosphere, and the humidity is measured by hygrometer instrument. The humidity is measured by hygrometer instrument. Okay, let's quickly have a look. Now we're entering to the next segment is plume. Is plume. What is plume? It is a path taken by gaseous effluents emitted continuously from a specific outlet such as vent, chimney, or stack. Now, depending on the condition, plume will be of different types. In case 1, when ELR greater than ALR, that means the super adiabatic condition, plume will be looping. That's the figure. In case 2, when ELR equals to ALR, it will be of neutral plume. In case 3, ELR less than ALR, plume will go up to certain height, then it will be stagnant, that is coning. In case 4, extreme inversion, when the inversion starts from ground and continues, it will be called as fanning. In case 5, that is a subsidence inversion, which is two conditions will be there. One is subsidence inversion, and then stack height is more than the inversion height. So if that, then nothing will come down, because at the above level first there is inversion, then your ELR greater than ALR. So that above gas will go take only the ELR super adiabatic condition, and anything, if anything wants to come down, it will get a lead of inversion. So nothing will come down, everything will go up. It is lofting, it is the best scenario. Case 6. The opposite of the subsidence inversion, residence inversion here. First there is ELR greater than ALR, then inversion, stack height will be less than inversion height. Generally what will happen here, as something is it will try to go up, but it will have a lead of inversion, and everything will come down quickly to the ground surface, and human beings will be exposed to the problem or exposed to the pollutant. It's the worst scenario called as fumigation. It is the worst scenario called as fumigation. And if inversion and superadiabatic condition is simultaneous, then that stack gas will get trapped in between two inversion layer, which is called as trapping. Now, effective stack height. So from this diagram itself, it is evident that this is the stack height, and this one edge from the height from which the stack is actually bending as per the atmospheric condition. So effective stack height is h dash, which is physical stack height plus plume height, delta h. And the plume rise is estimated by Holland's equation, by the equation delta is equals to VSD by U into 1.5 plus 2.6 10 to the minus 3 PD into TS minus TA by TS, where TS is the stack gas velocity in meter per second, D is the internal diameter of stack, wind speed in meter per second U, P is the pressure of atmosphere in millibar, TS is the stack gas temperature in Kelvin, and TA is the ambient temperature in Kelvin. Just have a look. Yes. So that is the end of the air pollution discussion. Hope you understand the thing. Just a recap of these things was there. And one thing I tell you, that if you don't have the Unacademy Learning app still, go to the Play Store and click the Unacademy Learning app and go for the install it, and after that go for subscription of GATE and EAC plus courses, where you will get personalized mentorship, best educators classes. Get subscription, and during taking the subscription, don't forget to apply the code SEN10 ACN10 SEN10. You'll get direct 10% discount. Great news that already launched Evolve for Get 2022 for civil batch A in English and Hindi both. Starts on 28th December. Already started, and this is the upcoming batch details. Have a look. Wherever you are applying, please apply the code SEN10 to get good amount of discounts. So that's it for air pollution engineering. So we have covered the non-watery part also. The next chapter will be the distribution system that we will cover tomorrow. Distribution system. Thank you for this session. Have a nice day. Goodbye.